Well, welcome back. We're going to be talking about programming timers in this chapter as we get more specific in our PLC programming. Let's first talk about mechanical timing relays. Mechanical timing relays are used to delay the opening or closing of contacts for circuit control. Certain of their contacts are designed to operate at the present time interval after the coil is energized or de-energized. Mechanical timing relays are used to delay the opening and closing, like I said, and then the instantaneous contacts change states as soon as the timer coil is powered. The delayed contacts change states at the end of a time delay, so you can be thinking about that. So for the symbols that are used, on delay provides time delay when the relay coil is energized. So this is a kind of nomenclature that you can be seen for that. For off delay provides time delay when the coil relay is de-energized. So we can see that, sometimes you need to let things settle down and you don't want to get false triggers. The on-delay timer is sometimes referred as DOE, which stands for delay on energize. When S1 is closed, TD coil is energized and the timing period starts. After a 10-second time delay period has elapsed, the TD1 contact closes and L1 is switched on. On delayed timer circuits that uses a normally closed timed open in the CTO contact. When S1 is closed, TD coil is energized, but TD1 contacts are delayed from opening, so L1 remains on. After 10-second time delay period has elapsed, TD1 contacts open and L1 is switched off. The off delay timer is sometimes referred to as a DOD, which stands for delay on de-energize. When S1 is closed, TD coil is energized and TD1 contacts close instantly to switch the light L1 on. When S1 is open, TD coil is de-energized and the timing starts, and after the 10-second TD1 contact opens to switch the light off. So in NCTC, we're seeing, so when S1 is closed, TD coil is energized, the T1 contacts are open instantly to switch light L1 off. When S1 is open, TD coil is de-energized, timer starts, and after 10 seconds, TT1 contact closes to switch the light on. So those are some various ways that you can have the delay on and delay off. For timer instructions, PLC timer instructions that provide the same instruction functions as timing relationships. The most common PLC timer instructions are TON, time on time delay timer, TOF, time off timer, and RTO, retention timer on. Here just are some quantities associated with the preset time, accumulate time, and time base. So you'll want to be thinking about those when you're dealing with trying to program for those things. Next, let's talk on delayed timer instructions. So an on delay timer is used when you want a time delay to occur before an instruction becomes true. And we can see this type of operation with this figure below. The Ellen Bradley SLC 500 timer file is file 4. So if you're actually using this, is the type of thing that you would be using. For the timer status bits, you have the enable bit, the timer timing bit, and the done bit. And so these are the things that we're trying to show in this table below. For timer words, the present value PRE word is the set point of the timer. That is the value up to which the timer will time. The accumulate value ACC word is the value that increments as the timer is timing. The accumulated value will stop incrementing when its value reaches the preset. The actual preset time is the time base multiplied by the value stored in the timer's preset word. Moving on, for this, the preset value PRE word is a set point of the timer. That is the value at which the timer will time. The accumulate value ACC word is the value that increments as the timer is timing. The accumulated value will stop incrementing when the value reaches a preset. So we're seeing this listed in this table. The actual preset time is the time based multiplied by the value stored in the timer preset word. For on delay timer instructions, the timer number is T4:0. That would be the syntax, which represents the timer file 4, timer 0 in that file. Time base is always expressed in seconds. It may be either 1 second or 1.0 second or 0.01 second. In this case, the time base is 1.0 second. The preset value is 15, the accumulated value is 0. Those are all the things that are listed. For the logic 5000 on delay timer instruction, we can see the things that would be laid out here in this figure. You can go to the textbook if you'd like to explore it further. Here is the PLC on delay timer program. And so it's too big to fit on one slide. So we're just breaking up between those two. For the TON status bits, the timer on delay, here we have the table showing how each bit is affected during the program operation. And for instantaneous contacts, the instruction programmed using an internally referenced relay coil. Here on the top part, we're showing a hardware relay circuit. A motor starts 5 seconds after a start button is actuated, and below is the equivalent generic PLC programmed circuit. For here we have a conveyor warning signal circuit. Here above is the hardware relay, where a horn sounds for 10 seconds whenever a start button is actuated, and below is the equivalent programmed circuit. For automatic sequential motor control system, so just going through this, the M1 is energized when PB2 is momentarily actuated. When the lube oil pump pressure switch PS1 closes, M2 and TD are energized to start M2 and begin the TD time delay period. After the time delay period of 15 seconds, TD1 contact closes to energize M3. Here is what this would look like if we had the PLC sequential motor control program, how we could set that up. All right, well, let's talk about the off delay timer instruction. So the TOF starts timing when the instruction goes from on to off or from true to false. And this is the kind of logic that would be associated with that. For off delay timer TOF program, here we can have the layout here. When the switch is first closed, the lamp is switched on. When the switch is open, timing begins and the lamp switch off after a delay of 15 seconds. If logic continuity is gained before the timer is timed out, the accumulated time is reset to 0. Here is a program for switching monitors off at 5-second intervals. This is the TOF status bits, and so the table showing each bit is how each bit is affected during the program operation. For instantaneous and time contacts, hardwired off delay timer relay circuits with both instantaneous and time contacts. So we have that. And for fluid of the pumping process, the process involves pumping fluid from tank A to tank B. Before starting, PS1 must be closed. When the start button is pushed, the pump starts. PS2 and PS3 must be closed 5 seconds after the pump starts. If either PS2 or PS3 opens, the pump will shut off and will not be able to start again for another 14 seconds. So some safeguards here. So here is the programming for the fluid pumping process. And so that gives you an idea of what that would look like.